Hi everyone. Today we are talking about triangle sum and finding the measure of the interior angles of a triangle. So let's get started. Specifically, we are going to learn what the interior angles of a triangle are, the properties of those interior angles, how they can be used to find missing angles inside a triangle, and how the sum of interior angles of a triangle can be used to set up equations. So just a quick review. Here are some real-life photos of right angles, acute angles, obtuse angles, and straight angles. And I'm going to go over those definitions right here real quick. You might want to pause the video and write this down. How many degrees does a line measure? Well, when we have an acute angle, the acute angle will measure anywhere between 0 but less than 90 degrees. A right angle measures exactly 90 degrees. An obtuse angle will measure more than 90 but less than 80. And a straight angle measures exactly 80 degrees. So again, pause the video, write these things down because they're very important for you to know. Here again is our real life examples of an acute angle. Well, first of all, a right angle, which you can see right here, an acute angle, which you can see here, an obtuse angle, which you can see here, and then a straight angle, which is right there. Each of these, well, not each of these because a straight angle will not do it, but the right angle, the acute angle, the obtuse angle can be in a triangle. If you have a right angle in a triangle, it is called a right triangle. And you will see this little box here at the right angle. If you have an acute triangle, that means that every angle inside the acute triangle are acute. Whereas this only has one right angle, an acute triangle has all three angles acute. An obtuse angle, or obtuse triangle, excuse me, is similar to the right angle. If you have an obtuse angle, it is the only angle that is going to be obtuse. That's the obtuse angle, and therefore this is an obtuse triangle. The other two angles are going to be acute, which we will talk about in just a minute of why that is. And then on a straight angle, there is no triangle unless, of course, you build it off from that. So what is a triangle sum theorem? What does this all mean? The interior angles of a triangle are the angles inside the triangle. So these are the angle A, the green angle B, the red angle, and angle C, the blue angle. And when you take those three angles and you put them together, such as what is right over here, you will see that they all line up on this straight line here, which is 180 degrees, because that's a straight angle. So we have a theorem, and that is called the triangle sum theorem or the interior angle theorem. It's known as both the interior, or the sum, excuse me, of the interior angles. And that is given as angle A plus angle B plus angle C equals 180 degrees. So if we know this theorem, if we know that all the angles of a triangle, the interior angles, equal 180 degrees, we can use that to solve for missing angles inside a triangle. So for example, this is number 1. We can see that this angle here, this blue angle, is 35 degrees. This red angle, because of the box, is 90 degrees, and therefore we can find this angle, the green angle, by setting up an equation. Just as we said angle A plus angle B plus angle C equals 180, we can go ahead and write, we will write, that angle A is 35 plus angle B is 90 plus angle C is equal to 180 degrees. And then we can solve that equation. This is 125 plus C equals 180. Subtract by 125 on both sides. And we have C is equal to 55 degrees. So now let's look at the triangle on the right. By the way, this is a right triangle because it has the right angle. Over here, triangle MAT, and we can label that as triangle MAT, is an acute triangle. And we will see that when we solve for angle T. So we can say that angle A plus angle M plus angle T equals 180 degrees. So that's 27 plus 82 plus T equals 180, or 109 plus T equals 180. Subtract 109 on both sides, and T is going to be equal to 71. And as you can see, 71 degrees, 82 degrees, 27 degrees are all less than 90. Therefore, they are all acute angles. So this is an acute triangle. And our last example down here, which I will do in blue, we have an obtuse triangle because this is an obtuse angle. And so we will say that angle A plus angle B plus angle C is equal to 180. That's 31 plus angle B plus 45 equals 180. B plus 76 equals 180. Subtract 76 on both sides, and we're left with angle B is equal to 104. Of course, angle B is greater than 90 degrees and less than 180 because it is an obtuse triangle. Now, up above, I said that a right triangle can only have one right angle, and the other two have to be acute. An obtuse angle can only have one obtuse angle, and the other two have to be acute, whereas an acute angle has all three angles acute. Why? Because if it's 180 degrees for every triangle, and you take away 90, that's the right angle. Let's do that up here. If it's 180 and you take away 90, you're left with 90 degrees. Therefore, angle A in this example and C have to split the 90 degrees, which will make them acute. And that is the same down here in the obtuse triangle, that if your obtuse angle is greater than 90, 180 minus, say, 90.5 is still 89.5, and two angles have to split that. And that's not the smallest I could make it. It could be 90.00000001, but it is the same idea as the right angle, that the two other angles have to split what's left over, and what's left over is less than 90. All right, let's do another example, and a little bit more complicated. Here we want to find each angle measurement and the value of x. So let's put this together. We have angle, we'll call this A, B, and C. So angle A is 7x minus 11 plus angle B, and I can put parentheses around here, but I won't need them because we're all just adding 5x minus 2, or combining, plus angle C, which is 2x minus 3. All of that is going to equal 180 degrees. So now if I take away my parentheses, since there's no multiplication, and I combine like terms, 7x, 5x, 3x, for one set of like terms, and negative 11, negative 2, and negative 3 for my other set of like terms, I get 12, 13, 14x minus 11, 12, 13, 16 equals 180 degrees. Using inverse operations, the opposite, I add because I'm subtracting. I'm left with 14x equals 196, not 196, excuse me. Divide by 14, use the opposite or inverse of multiplication, and x equals 14. So now that I have x, I can plug that into each of these x's and find out the angle measurements. So angle A is equal to 7x minus 11, and I am going to substitute that in. The x is 14, so 14 times 7, or 7 times 14, minus 11 gives me 87 degrees. Angle B is equal to 5x minus 2, and I will substitute in 14, and I have 5 times 14 minus 2, and that gives me 68 degrees. And last but not least, I have angle C, which is equal to 2x minus 3, and substituting in 14 here, 2 times 14 minus 3 is going to be equal to 25 degrees. Now, if I did this correctly, these three angles should equal 180 when I add them up. So 87 plus 68 plus 25 equals 180 degrees. So I did it correctly and I checked my work. So these are the three angle measurements, and this is value of x. And that is all I have for you today. So if you're in my class, this is what we're working on, and see you next time.